Number 5. Determine whether it's inductive or deductive reasoning. Every Wednesday, JC's mother calls. Today is Wednesday, so JC concludes that her mother will call. What's key things to remember with inductive? Inductive is patterns. Deductive is rules, theorems, facts, something. So which one is this? Inductive. Next question. 20. Draw a valid conclusion from the given statements. If possible, then state whether your conclusion was drawn using law of detachment or law of syllogism. If no valid conclusion can be drawn, then write no valid conclusion. Ballet dancers like classical music. Let's write these as an if and then statement. If I say ballet dancers like classical music, what's the if part going to be?
Ballet dancers like classical music.
Be careful. If what? If you're a ballet dancer, then what?
You like classical.
Then like classical music. Again, this part's called the what? Hypothesis. This part's called the conclusion. Very good. Let's see, what else do they tell us? If you like classical music, then you enjoy the opera. So that one they've already written as an if and then statement. If you like classical, ignore that, music, that's an I, then enjoy opera. Okay, this is the what? Good. This is the last time when we were talking about the two laws. Law of detachment. Law of detachment, remember, used one whole statement and then just the hypothesis, or just half a statement. Is that what this one has? No, it's actually got two whole statements, right? If it's got two whole statements, then it was the other law. What was that other law? Syllogism. Law of syllogism. So it looks like maybe we could be using the law of syllogism. To use the law of syllogism, one thing has to be true. What's that one thing?
First hypothesis and the last conclusion.
You got them backwards.
The last conclusion and the first hypothesis.
You said the same thing, but you said it backwards. What two parts have to be the same? The first conclusion and the second hypothesis. Are they the same?
Yes.
If they're the same, make sure you're watching this, because law of syllogism is an art. If this ends, the first statement ends with what the second statement begins with, then we can use the law of syllogism just to put this part, oops, went too far, and this part together to make a new sentence, and that new sentence has to be true. So all you're going to do, are these two the same? Yeah, these two are the same. So we just take this and put it together, and that's our new sentence. That's our conclusion that we can draw from the information we're given. So what's our new statement going to say? If you're what? You're a ballet dancer.
Then you enjoy opera.
I could write here. Then you enjoy opera. What do we know about that statement? Is it true or false? It's true. That's what the law of syllogism tells us. We make up this new statement because of the law of syllogism. This has to be true. Now, Clifton's looking at it and going, I know some ballet dancers and they don't like opera. Well, that might be, but according to our laws, that's the way it's supposed to work, right? And there's going to be exceptions to just about everything.
Spending it
All right. As long as you don't really think I believe that every time you tell me that. Because then I think, oh, you know what, Kai thinks you're an idiot, Ebersole.
on. What is this doing?
Next question.
22.
22. Same kind of setup.
Yeah.
So I'm not going to read all those directions again. If a polygon is regular, speaking of which, what is a regular polygon? That's a polygon. What's a regular polygon? All the definitions tests that we're going to be taking. Sorry, that's supposed to be a comma there. The definitions test that we're going to be taking, guess what one of the terms on it is? A regular polygon. So you might want to listen closely now to make sure you know what a regular polygon is. What is a regular polygon? What's it mean for a polygon to be regular? All the sides are the same and all the angles are the same. So in a regular polygon, all sides are the same length, all the angles are the same measure. So, let's see here, if polygon is regular, then all sides congruent. What's this part called again? Hypothesis, good. What's this part called? Conclusion. Let's see what else they tell us. All sides of WXYZ are congruent. So all sides of WXYZ. How many sides does WXYZ, how many sides is it going to have? 4. Same as the number of corners, right? Angles and sides, number has to be the same. So all sides of that are congruent. Then we got 2 full statements here. No, we got 1.5, right? So can we use the law of syllogism like we did on the last one? No. So what's the other law? Detachment. Right? I'm not going to spell it all out, but detachment. Remember, with the law of detachment, what has to be true about this hypothesis? It has to be the same as the half statement, right? Those two have to be the same. Are they the same this time? No. As a matter of fact, this is actually the same as the conclusion, right? So can we use the law of detachment? If those two aren't the same, can we use law of detachment? No. So can we draw a conclusion from this? So we write no, I think they said write no valid conclusion. One last time before we go on. Law of detachment. If I have this, it's going to look like this. If, and I'm just putting A in there to stand for my hypothesis. Then B stands for the conclusion. For the law of detachment to work, the second thing that they tell you here has to be A. Those two have to be the same. Then what can we say about B? We know that B all by itself is true. That's the law of detachment. Law of syllogism. It's going to start off saying something like this. If A, then B. What's the second one going to have to say to be able to use law of syllogism?
If B, then
It's got to start off with whatever this ended with, right? If B, then, who knows, C or whatever. So these two have to be the same. And then we can put together a new statement saying if A, then C. Law of detachment, law of syllogism. Don't make them harder than they are. I know that they're sort of confusing, but. Walk up here, grab the notes. There's also some examples on another sheet. Grab that sheet. Both of them will go into your binder.
So much glitter in there.
Yeah, somebody's gonna be unhappy with the second vote. I don't care. I'm not gonna sit there so yeah, I don't think we can go back together. There's this little piece right here that I think we're. Let me find mine, and I'll give you a new one. You just go back and retract. First part, is this on your notes? Did I put this on there? I think I did, didn't I?
Yeah.
All right. All we're going to do with this is just reviewing some of the stuff that we've covered already. Writing if and then statement, converse, inverse, contrapositive. Just real quick, what's the converse do to a statement again? Switches it. What's the inverse do? Negates. What's contrapositive do? Both. First, let's write this as an if and then statement. What's it going to say? If what?
If any 2 points, then exactly one way.
So let's make it make sense. If,
a line through any 2 points.
now you're turning it around. So if you have what?
If you have 2 points.
All right, so, and we can shorten it up and make it, it doesn't have to make great sense, but if 2 points, then what do we know?
It is exactly one line.
Then exactly one line. We talked about this earlier this year, right? You pick 2 points anywhere in the world. How many lines are there that connect those 2 points? One. All right? This part again is called the what?
Hypothesis.
Hypothesis. This part's called the conclusion. Good. It's all right if I abbreviate some of this stuff like converse, just put CON. Is that all right? Everybody gonna understand it? So what's the converse?
If exactly one line, then any 2 points, or any 2 points.
If exactly one line, and I probably should put if to make it make more sense. If you have 2 points, right? That way, when we switch it around, so if exactly one line, then what do we know?
And there's 2 points.
You have 2 points. Ignore the stray marks going up. We should have done this at the beginning and I didn't do it. Was the original statement, was it true or false? It was true. I told you that like second day of school, right? First day of school maybe. 2 points make a line. How about the converse? Is it true or false? If you have a line, then you know you have 2 points. That's true also. Last class or the class before, I can't remember which one it was, but we said if the original statement's true and the converse is true, that's called biconditional. And we could say, if you have 2 points, or you have 2 points if and only if you have exactly one line, using that if and only if. Biconditional, both the original statement and the converse are true. Inverse, what's the inverse do? Negates it, so how am I gonna write it?
You're gonna write if you don't have 2 points.
So if
One line.
don't have 2 points, then what?
There's no line. Then there's not one more.
All right, then not exactly one line. So let's think about this one. If I don't have 2 points, what could I have if I don't have 2 points?
4.
3.
Could have 3, could have 4, could have 1.
Could be 0.
Could be 0. Then not exactly one line. Is that true? Sort of hard to understand it because it's got so many knots in it and stuff, but contrapositive.
That is where you do both.
You switch it and negate it.
If there's not one line,
Passes landing.
there's not
Going off.
a line, then there's not 2 points.
If not one line, if that's supposed to be a 1 there, then
No 2 points. Or,
not.
yeah.
I don't know, this doesn't, mine doesn't make any sense whatsoever, but I'm tired of writing. So if not one line, then not 2 points. Is that true or false? Remember, we said, even though the contrapositive is usually hard to understand, if the original statement's true, what's going to be true about the contrapositive, or what do we know about the contrapositive? It's probably true also. Go ahead and start trying to solve that first one. Sorry. Sean, you remember how to solve all these? No? I'll have to go over and talk to Mrs. Barnes. Get her over here. See. Oh, you didn't. Then that wouldn't do me any good, would it? First one, how do I solve the first one?
Add 6 to the other side.
Add 6 to the other side. Does anybody remember when you were in algebra last year? You added 6 to the other side. Some teachers teach it this way, some teachers might teach you to do. Ken's got to stop doing that. Some teachers teach to like put a +6 here and a +6 here. Rewrite it that way. I don't know which way your teacher taught you. It doesn't really matter. All ends up being the same thing. I do it up and down. What happens with the 6s over here?
Cancel out.
What's left? On the other side, -4 and a +6.
That's 2.
2. What we're going to do today, you're going to do all that same stuff, but you got to give me a reason why you did that. And your teacher last year in algebra taught you this, and you went over it for like one day, And then after that, Michael just didn't even care about the reasons. He just knew what to do, and he just did it. All right? Does anybody remember what says that we're allowed to add 6 to this side and 6 to this side? Some kind of property. Does anybody remember any of those properties? It's like distributive property, except it's not distributive here, because distributive is when we have the parentheses and you do that, right?
Additive property.
Sort of. It's the addition property of equality. How do I solve this next one? Divide both sides by 3, and you end up with what?
7.
X equals 7. What property did we use there?
Division property of equality.
Division property of equality. And you learned all these properties last year. Like I said, you learned them for probably one day. She told them to you.
We had a paper that
Yeah,
was
we
like
had
a
a paper.
list.
Yeah, I
And-
think
and
we
it was
might
also-
have over it too.
It was also on one of our tests, but I definitely got it all wrong.
Now, the good thing with Mrs. Barnes, if you had her, is she used to teach geometry. So she knows what I'm going to go through this year with you.
She gave us papers to keep for this year. She told me to keep.
So she does stuff that she knows is going to lead into geometry, and that's like this. So what we're gonna do today is you're gonna do the steps and solve the problems, and you're gonna have to give a reason each time. All right? With these proofs, if you learn nothing else for the rest of this chapter, what you're doing here is thinking things through logically. So make sure that you can think things through logically and be able to support your argument. All right? And that's what this is doing. When I write this down, whoever looks at this next knows that what do you have to do to solve this equation? Divide. Got to use the division property of equality. That's what we're getting ready to go into deals with. Next one, how do I solve this one?
Yeah, subtract 30,
Subtract.
37.9.
That's not supposed to,
What?
that's number 37,
Oh, I
sorry.
was gonna say. I was like, what?
Yeah, it does look like it, doesn't it?
Subtract 9.
Subtract 9 on both sides. Those cancel out. That leaves you with x equals what?
4.
What property did we use there?
Subtraction property.
Please make sure, don't do this. I'm going to let you abbreviate a lot of stuff as we go through and do this stuff because I don't like the writing any more than you do. Don't abbreviate this as sub. Why not? Are there other properties that might be that?
Yeah.
Yeah.
What's another property?
Substitution.
Substitution property. So when you're doing subtraction, can't abbreviate it. Subtraction, property. You can abbreviate the other words like property, of, and you can abbreviate equality like an equal sign to make it shorter on yourself and stuff. But subtraction and substitution, you can't abbreviate because I don't know which one it is. Next one, these are always the ones that are the funnest because everybody hates these and I don't understand why. Because it's got a fraction in it.
It's
What do you do?
You multiply by 5.
Multiply both sides by 7. If you're dividing by 7, the inverse or the opposite of that is to multiply by 7. Should that be harder than any of the rest of these?
No.
No, it's just nobody likes multiplication, nobody likes fractions. So they start,
X equals 35.
x equals 35. What did we use there?
Multiplication property.
And again, you can abbreviate multiplication property of equality. Something like that maybe? Fill in what you need to fill in on this part. So the addition property of equality, all of these, all four of these properties, is when you do same thing to both sides of the equal sign. If you had Mr. Harrison, I think, I don't know if he still teaches this way or not, but he used to always teach a balance, a scale, when you're doing algebraic equations. And if you add 6 on this side, what do you got to do to keep it balanced? Add 6 to the other side. All right? So all these are that same thing. So here, I added what to both sides? C. Here I did what? Minus C on both sides. Here I multiplied both sides by C, and here I did what? Divided both sides by C. Use the abbreviations to make it easier on you. Might want to circle this and put do not abbreviate. Pretty bad Ebersole uses an abbreviation to tell you not to abbreviate, right? Sort of ironic, is that what that's called? Ironic when you...
Yeah.
What are some other properties that you had in algebra? You guys told me at least one.
Substitution.
Substitution,
Distributed.
distributive property. Look at your paper now to find them.
Symmetric and transitive.
Fill in what you need to fill in on these two. Please make sure these notes are getting into your binder where they belong. I think my friend got lost.
Your friend.
Bye.
I bet you just sit in the bathroom.
You think he's asleep?
Probably. I don't know why he can't sleep in here.
He probably took his phone with him and I wouldn't let him use his phone, so he's probably doing something else.
Yeah.
Breaks my heart. You can tell that, right, Hannah? Now, Hannah, if it was you, I would be upset. Because I think you actually learned. And I'm hoping I'm actually doing some good with you. Other students, not to mention any names, I don't know that I'm helping him any, or helping them any, I should say. Because I don't want to mention anybody. Substitution property, with the substitution property. Write this with it. Used a lot. Substitution property is used a lot. Get worried about it. Thought maybe you got lost or something. With substitution property, use it a lot. One of the times you use it is when you have like terms. If it's just like terms and you're just putting together like terms, like 3x plus 4x. What is 3x plus 4x?
3x plus 4x, so
7x. When you do that step, your reason for that can just be substitution property. All right? So anytime you're just putting something together, substitution property. Substitution property gets used a lot. A lot of different places that you could just stick in substitution property. Now there's other things like we could put in, for that we could put in added like terms or something along those lines. Just use substitution property. If you, as a reason, as we go through and we do these 2-column proofs that we're going to do, and you put in substitution property as a reason, probably a pretty good chance that it might be right. All right, a better, I shouldn't say a good chance, because if you put substitution property for everything, a lot of them is going to be wrong. Okay? So don't try that. I had students in the past that, well, you said substitution property, it gets used a lot, so I just wrote substitution property for every reason. Well, it doesn't work that way. Distributive property. On distributive property, you might want to draw in these arrows. I'm guessing that your algebra teacher probably drew that stuff in each time you did distributive property, right? What if I have something like this? 5x times 3 plus 4. Do I want to use distributive property on that? What do you want to do first? Do the inside first. If possible, make sure you look at the problem carefully. If possible, do the inside first. Don't distribute out here, because all that does is confuse everything. Then Clifton, a lot of times, Clifton ends up making some little careless mistake and getting the problem wrong. So you do this, just add those two. Then what are we going to do with this and this? Multiply, right? And then what could our reason be when we multiply? Substitution property. All right? Just because we're just multiplying. We're not multiplying both sides by anything. We're just multiplying two things together. Our reason here for 3 plus 7, or 3 plus 4 is 7. Again, substitution property. This one's probably new. We're going to use it a lot in geometry. This one you learned in algebra, but you probably didn't do a whole lot with it. This one you learned in algebra. Probably never really paid a whole lot of attention to it because it was so easy. These properties, you're going to see these 3 properties over and over and over again for the next week or so. Because not only do these properties work in algebra, they also work for segments, and they also work for angles. You all right? You all right? You act like you're hot or something.
Just trying not to go to sleep.
Let me help you out and spray you with my water bottle back there.
No.
I can poke a hole in your water bottle and just as I walk by, just squirt you with it. Now you did. Reflexive property. We're going to use the reflexive property a lot in geometry, and it sounds stupid, and it sounds like it's not very useful, but it is. All right? In reflexive property, anything equals itself. Okay? Not Sean equals Cooper. Has to be Sean equals Sean. Anything equals itself. So 5 equals 5. You didn't use this a whole lot in algebra because everybody knew that 5 equaled 5. And you didn't put a whole lot of thought into it. But in geometry, we say things like, somebody read this to me.
Angle A is congruent to
Angle A is congruent to angle A. Now, the reason this is important, because later on in the year, we're going to get into stuff like this. And if I say that's N, A, T, I, how many triangles in this picture? 3, right?
Yep.
We're going to care about the 2 smaller ones, because guess going to end up being true about those two smaller triangles?
The same.
They're the same. And we're going to prove that they're the same. Well, one of the steps in proving that they're the same is when I separate these two triangles, what do you notice about this side and the triangle on the left and this side and the triangle on the right?
Same.
It's the exact same segment. They're both segment AI. So what we're going to have to say in there is that segment AI is congruent to segment AI. So on our definitions test and stuff that we take, one of the things that I'll probably put on there just about every single time is reflexive property. And all you've got to write for reflexive property is anything equals itself. That's reflexive property. Symmetric property. What does symmetric property do? Switch sides. You did this a whole bunch in algebra last year. You didn't know you were doing it. All right? Because you were solving an equation and you ended up with this. And then when you went to write down your answer, what'd you write down?
X equals 3.
What property did we just use to switch that around? You didn't know you were doing it, but you did it probably every time. You switched it so that the x came first. Transitive property. Transitive property says if A equals B and B equals C, this is sort of like the law of syllogism. What do you notice about these two right here? They are the same. Then what can I do with this part and this part? Put them together, just like in the law of syllogism. So if A equals B and B equals C, then A has to equal C. That's the transitive property. A proof, this isn't anywhere on there, write it in there somewhere. I don't want to tell her that I'm blaming this on you. She gets mad. She didn't understand what I was saying about her phone, did she? So a proof is a logical argument in which each statement is supported crap, I forgot. She had glitter all over this chair. Now I have glitter all over my butt all day long. People like Sean will be laughing at me because I got glitter on my butt every time I turn around up here at the board. No laughing, Sean, or I'll make you come up and wipe it off. I shouldn't have recorded that. That's probably a logical argument in which each statement is supported by a reason. When you have an argument with your parents, you make a statement, you've got to do what?
Back it up.
Back it up, support it. All right? That's what two-column proofs, or that's what any kind of proof does. All right? It's got to be some kind of support. There's got to be some kind of support there. You got to tell whoever looks at this next, I did this because of this rule. I did this because of this rule, or property, or theorem, or postulate, whatever it happens to be. Fill in what you need to fill in on this slide. Also put this in there. A two-column proof is also called a formal proof. Unlike in English class. Everything in math class is sort of backwards to everything in English class. The way this is set up, this looks like your what in English class if you were going to write a paper? A rough draft or an outline. That's not your formal paper, right? That's your informal. You turn in your outline or whatever, they look at it and say, okay, now write your paper. In algebra class, this is the formal setup. Why do you think it's called a two-column proof?
There's 2 columns.
There's 2 columns. Real difficult. You're always going to have some kind of given information. It's always going to say this, given, and then it'll give you some kind of information there. You're going to have a prove statement. This is what you're trying to prove. This is what your argument's trying to get you to. The 2 columns, the first column, statements, whatever statement you're making in here. The second column, the reason for each of those statements. Please make sure that you number all your statements and reasons because they have to match up. All right, they have to match up. So I know that statement 1 here matches up to reason 1. I know statement 2 matches up to reason 2. They won't always have just 4 steps. It could be 3 steps, it could be 5 steps, whatever. It could be however many it takes to make your argument. All right? That's a 2-column proof. That's what it's going to look like every time. You're going to have given information, what you're trying to prove. You're going to set up your 2 columns. First column is going to be your statements. Second column is going to be your reason. The first column is sort of where, I hate to put this, but it's almost like where you're showing your work. I hate to put that because I'm going to tell you here in a minute not to show your work in these algebra stuff, in these algebra proofs. The reasons always have to be. They can't be anything else. Properties, definitions, theorems, postulates, axioms. You're never going to say, because 2 plus 3 equals 5. You're never going to say that. That won't be over here. It's got to be some kind of property. If it's 2 plus 3 equals 5, then we're going to say because of addition. Or we're not going to say because. We're going to say addition property. So on and so on. The other thing that could be over here, and will come most of the time, and you might want to write this in there for number 1, the one that most of you are going to learn to love, because you're going to get free points for it, given. What do we normally start off our argument with? Whatever we are given. Right? Whatever we're starting with, whatever we know to start. So a reason could be given. Now, can every reason be given?
No.
If it was, then you wouldn't have much of an argument. It'd be a stupid thing to be even arguing if it was all just gave to you. On the worksheet, that's the second page there. We're going to make a 2-column proof for each one of these. I'm going to show you how to do the first one, then I'll probably let you try the second one on your own. First thing, usually I don't like drawing the 2 columns right off the bat. I like going through and doing the problem first and everything. But since we're running low on time, I'm going to do it this way. We got our statements here. Reasons here. Number them. What's statement 1 going to be? What's the first thing we're going to do to start this problem? before that?
We're going to
Write the problem down, all right? If you were doing a problem in the algebra book, you'd probably write it down first. Our reason. This reason's got to go with this. How did we know? Sorry, I forgot my 1. How did we know that 3x plus 1 equaled 7?
Because it's what's given.
That's what was given. They gave it to us. So we just write given here as our reason. When we're doing these on a test or a quiz or something, you just got 2 points. Get a point for this, a point for that. Now, when you're doing these 2-column proofs for algebra stuff, we don't want to do the work in here. So that might be why you need to maybe come out here and do the work off to the side or something so that you can do what you need to do. What's the first thing we need to do here? Subtract 1 from each side. When I subtract 1 from both sides, what's that leave me with? 3x equals 6. Everybody agree with that? What allowed you, this is the hardest part, this is the part that most students have the most trouble with, is the reasons out here. You make an argument with your parents, this is the part that you have trouble with, is giving them a reason why. Just saying because or please, that's not a reason. All right? What did we use to go from step 1 to step 2?
Subtraction, property, or
Do I want to abbreviate this?
no.
So subtraction, and you can just write subtract if you want. Property of equality. Number 3. What do I do next?
Divide through.
You don't have to. Now some of the problems in this book, they will. All right? They'll show the work. Some books say to show the work, some books say not to show the work.
What do you say?
I'd rather you didn't. All right? So on this, let's not. But I say that, then they're going to give you a 2-column proof where they just leave blanks and give you part of the 2-column proof, and they're going to show the work, and then you're going to say, well, you told us not to. Why is this book doing it? They're showing different things each time, all right? So different books teach it different ways. Here, I'm not going to show it. What's the next thing that we do?
Divide 3.
Divide by 3, and you end up with x equals what?
2.
Make sure you divide. What did we use to go from step 2 to step 3? Division, property of equality. What's our next step?
That's it.
Good answer. There is nothing else, is there? Did we get to what we were trying to prove? That's what you look at. What were we trying to prove? Well, we were trying to prove that x equals some number. We did that, so we're done. That's our 2-column proof.
I thought people hated these.
Yeah, they're not hard enough. How many points would this be worth on a test or a quiz? 6 points. Just looking at this is the part that always kills me, because not all of them are going to be this easy, but this is worth 6 points. This is the part that bothers me. It's worth 6 points. When we do these, because people hate them so much, we do them on a test or quiz, people just leave them blank. We know it's worth 6 points. Should anybody miss this point? It was right here. All you got to do is write it down. So that's 1 point. Should anybody miss this point? That's given to you. That's another point. You went through algebra. Should you miss this point? You went through algebra, so should you miss this point? So now you got 4 points out of 6. Maybe you don't understand the properties. I hope you understand the properties, but maybe not. So you missed both those. You still got 4 out of 6, which is a 67%. Which is better? 67% or 0%? By a lot. Try the second one. Yes. Yes. Sure. Mr. Smith, they want you in the office. You didn't do something silly, did you? Keith, did you understand me?
Yeah.
You're gonna get some stuff in. Might wanna take your stuff with you, Kyle. I don't know what they're doing. How much time we got left? I don't know. You'll probably be all right. Another thing, just because I like Kindle so much, make things easier on you. Your two columns, if you want to go that way and just write S and R, I won't throw a big fit about that either. You guys don't have to write anything because I already put them on there for you. But so when you're doing these somewhere else, I don't mind. On number 2 here, what's our first statement going to be?
Or X equals 32 and the reason.
And our first reason, give. I seen some of you, Clifton up here, did that part and then stopped because he got confused a little bit. What's the next thing you do to solve that? Sometimes it might help. Even though if we're not doing the work right here, then come out here to the side or up to the top or somewhere and do the work.
That's subtraction.
What do I do next?
Subtract 5.
You want to get all the x's on one side, don't you? So do I want to subtract 4x?
No.
Even though 12's bigger and your algebra teacher told you to always take the smaller one to the bigger one, this time it's probably going to be easier to take the bigger one to the smaller one. It's going to make everything shorter. So I'm going to subtract 12x on both sides. What's that leave me with? Negative 8x equals 32. What did I do to take the 12x to the other side? Saying it back. Subtraction, property of equality. Now what? X equals negative 4. What's our reason? How did we go from 2 to 3? Division, property of equality. What's our next step? That's it. All right? Did we figure out x equals some number? Yeah, so that's all the farther we go on this. I didn't put what x equaled on each one of these, just because I've had students in the past who already know what x is, so what do I got to do this? Just being a knucklehead, and so I didn't have to deal with knucklehead stuff like that. I didn't put what x equaled on them. Next one. Statements, reasons. Give you a minute or two, try it. Again, if it helps you, work it out first. Go off to the side somewhere and just work out the whole problem first. Keith, you with me? Still trying to get woke up? What's our first statement gonna be on this one?
Parentheses, 2x plus 11, parentheses, equals 9.
How do we know that that was true?
It was given.
That was given to us. What do we do first? Start to solve this.
Distributive property.
You distribute out here, right? So what's 3 times 2x?
6x.
What's 3 times 11?
33. Equals what?
Ignore that straight line going up through there. What did we use there?
Distributive property.
Now be careful.
It's not.
It's not of equality, because of equality tells you when you use of equality, that means you did it to both sides of the equal sign. Right? So if you just do something on one side of the equal sign, you don't have to have that of equality. So if we're just doing addition, then you write addition property, not of equality, or distributive. Sorry, I like to abbreviate because I always misspell everything. Is that gonna be all right? Can you guys understand that?
Yeah.
Distributive property. That way I don't have to worry about my spelling. What do we do next?
You're gonna subtract.
Subtract what?
33.
33 from 9.
Subtract 33 on both sides. What's that leave us with?
24.
What's on this, the left
Oh,
side?
I'm sorry, 6x equals 24.
Close.
Negative 24.
What did we use there? Subtraction again, don't abbreviate subtraction. You can put subtract or something because substitution property looks a lot like it. Subtraction property of equality. Are we finished?
No.
Now what?
X equals -4.
X equals -4.
And you divide it.
So what do I put? Division property. Ignore all those stray marks going up through there. Of equality. Let's run through these last 3 real quick. Statements, reasons. What's our first statement gonna be?
I don't know.
Leave it where it's given.
Plus 12x equals 8x.
28. Ignore that. 28 plus 12x equals 8x minus 4. How do we know that?
Because they told us.
It's the first thing we do here.
Combine 12x.
We want to get the 12x and the 8x together, right? Now, can we just say combine them?
No, you have to
No, because they're on opposite sides, right? So we subtract what?
12.
Which one?
8.
It doesn't matter which way you go, but normally your algebra teacher, again, told you to take the smaller one to the bigger one. On the other problem that we did a while back, we took the bigger one to the smaller one just because it made it one less step. This time it's going to be easier to take the 8x to the 12x. What's that leave me on the left side if I move that 8x over there? 28 stays the same, plus 4x equals -4. Don't forget that negative there. What did we do there? Subtraction property of equality. We did the same thing to both sides. We subtracted 8x on both sides. What next? Subtract 28 on both sides. What's that going to leave you on the left side? 4x. How about on the right side? Be careful.
-32.
Very good. -32. What did we use there? Same thing, subtraction. Is that all we're ever going to use, the subtraction property?
No.
We've used it a whole bunch. And it's just Ebersole, for some reason, got stuck on the same kind of problem over and over again. Are we finished? Now what? So x equals what? What's our
That was division property.
division property of equality? Are we finished?
Yep.
Yeah, that one's done. Next one, look at the next one. Sorry, I was trying to look at one to answer the questions that Cooper was asking a few minutes ago. With, all right, what, if they do show their work, because they write in some other crazy stuff, and we'll have to go over that here in a second. Statements, reasons.
6x plus 17 equals -7.
Please make sure that you are numbering each statement and reason so that I know what matches up to what. How do we know that that was true? Given. Next thing.
Subtract 17 equals
So 6x equals what? Have your neighbors take off their shoes if you need to.
-24.
Okay. Did you have Keith take his shoes off so you guys could count it up? You didn't? Did my joke just go right over the top of your head and you didn't understand? What did we use there? Subtract property of equality. Then what? X equals -4. Was every answer -4?
Yeah, most of them.
Was? Well, I really got stuck on something, didn't I?
Most of them maybe
Division property of equality. Statements, reasons. What's our first statement gonna be? Parentheses.
Parentheses x minus 6 equals x, parentheses 16.7.
How do we know that? First thing you're gonna do.
Distributed property.
So distributed property, if I do distributed property first, there's many, many different ways you could do some of these problems, but if we do distributed property, what's that give me?
-10x.
6x.
Oh, sorry, I went too far. 6x minus 30. 16x.
Now, watch on this one, because should we use distributed property on this?
No.
No, so I'm gonna leave it that way. If you did, it's not a big deal. It would still work out as long as you don't make some kind of mistake. But I know over my many years of teaching that when students do this the wrong way, they make some kind of mistake. What am I gonna do there? Just subtract. So I end up with 6x minus 36, that stays the same on that side. That's a minus sign. Equals x times 9 or 9x, right? Does it matter if I write, which way I write it? What did I do there? I just did what? I just subtracted. Did I do subtraction property of equality? No, because I didn't do it to both sides. So what you could write right here, the easiest thing to write, substitution property. Anytime you just do addition, subtraction, combining like terms, whatever, substitution property. What next? If that confuses you to have x times 9, then change it to 9x, that's fine. Now what are we gonna do? Move the 6x over. What's that leave us with on the left side?
Negative 36.
Subtract 6x on both sides. What do we have on the right side? 3x. What do we use there? Clifton says subtraction. Is it just subtraction? Property of equality, because we did it to both sides. Now what? Divide both sides by? What's that leave us with? Negative 12 equals what? X. What do we use there? Division, property of equality. Are we finished?
No.
They wanted an x equals some number, right? So what do we need to do to it? Flip it around. So x equals,
And that was false.
which property was that?
I'm looking. Oh, symmetric property.
Symmetric property. All symmetric property does is switch the two sides. Now are we finished?
Yeah.